It should go live in a minute. Then we are good. I find it funny whenever I set up the stream and it goes from Zoom to YouTube or Zoom to LinkedIn in the past. It feels as if it's like walking there. Takes a while. Okay, good. We are live. Okay. Thank you, everybody. Okay, we're going to get started. Hello, everyone. I'm Sudha Jamthe, and this is Weekly Vet at Business School of AI. This is our weekly speaker series, global speaker series, where we bring a speaker, have a fun discussion, and learn the latest, greatest topic in the world of exponential technologies. And we've been doing this series on generative AI. And in my past, many of you have taken autonomous vehicle courses with me. We have had a course on digital twin already here in Business School of AI. And today is one of those days where everything comes together. And before I get started, I have some logistics. I am a technology futurist joining you from Silicon Valley. In the Zoom room here, we have our speaker waiting to talk to us, Sneha Jadhav. And we have some of you who are joining on Zoom. My students I see from Stanford and Barcelona Technology School and from Business School of AI. So it's my happy hour to get to meet you all. But instead of just chatting with you, I get to host this because I'm filling in for Yashashwini, our regular host. And for logistics, we are streaming this on YouTube. And thank you, Deepika. She's going to be recording this so that we can bring you the recorded versions because people have been asking, okay, can we go watch this because we missed this week? And we are switching to the 9 p.m. in California time, 9 p.m. PT, which was our usual time. We're switching back to that starting today. So no more getting up early for the West Coast people. But for those of you from Europe and Nigeria and India and everywhere else, thank you for joining us. I hope this hour works better for you. Okay, so digital twin, what is digital twin? And for those of you here on the Zoom, if you don't want to be recorded, go off camera. If you don't want your voice recorded, don't speak up. But we want the engagement. So post your questions here on chat. And I will make sure that I'll bring it up to Sneha so we get all our questions answered. And I'm going to go check in on YouTube, but it will be delayed. If you're watching on YouTube, you're welcome to post your questions, but I'm going to make sure that I bring you the answers also. Okay. So what is digital twin? So if you have taken any of my courses, you would know that I talk about digital twin a lot. I love digital twins. I love the concept of digital twin. So before I jump into today's topic, so today's topic is digital twin with agent AI. So it's kind of like bringing the agent AI, the hot topic under generative AI, with digital twin, which is about devices and cars and industry. So if you already have an idea of what this topic is about or how digital twin meets agent AI, I would love to hear from your guess on how is it going to meet, or what kind of digital twin do you think is agent AI going to meet? Okay, so feel free to chat away. It doesn't have to just be questions. Okay, so what I've done is I went back and dug up that old video about digital twins because this is something that I used to show in all my classes. And this one is about 7 years old, pre-generative AI, pre-LLM world. But the digital twin concept is the same. So let me see if I can show you that. Okay, just let me get out of other windows. I had set it up in a window. I had a hard time finding that because the concept of digital twin was introduced by GE. And I had some students from GE who were taking my IoT course at that time. Let me bring this window. Do you see this? Yeah. Okay. Let me show you the video. So this is GE when they introduced digital twins, the concept of digital twins. Okay. This video is about 7 years old, and I think the original one is even before that.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing and my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the Opflex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
Hey, good morning.
Okay, guys. So I need to get out of Colin's presentation. But this was the digital twin from the past, talking to a turbine and a digital representation of the turbine that GE created. The world has come a long way, but they could not chat with the device. They could not run these thousands of simulations that they're talking about and automate it in a way that they could actually get to this kind of result. So that is where we are heading today with our exciting topic of digital twin meets AgentAI. So I'm going to bring Sneha here. Welcome, Sneha. So I'm not going to spend too much time on Sneha's intro, except that she's the person who introduced me to digital twin. I say this of many of my students, and I'm so grateful for that. And this is really the truth. It's not like 3 people told me about it, and Sneha happened to be one of them. Sneha actually built the very first digital twins in Cummins many, many years back. And we've had many discussions about digital twin and how you build it and what is the purpose as I was teaching autonomous vehicles. And, it is part of many devices. So we are creating a digital representation of anything. I mean, now we can even go to a place where there's a digital representation of the driver or a human. I'm not going there. I think we're going to stick to devices, right? Okay, so why don't I pass it on to you? You have permission to share the screen, but get started. Tell us a little bit more intro other than you built the first digital thing at I'm aware of.
Well, good morning, good afternoon, good evening, everyone. Thank you so much, Sudha, for having me. It's always a pleasure to be on this side. And I'm really glad to be here. So just a quick logistical thing. I'm not able to share my screen.
Okay, then as you get started introducing yourself, I'm going to make you co-host.
Okay.
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 You should be able to change. You will be able to share.
Yeah. Can someone confirm you can see my screen? Can you see my screen?
Yes, Sneha, take it away.
Thank you. Okay. So anyways, quick introduction about me. I'm Sneha Jadhav. I have about over 10, 12 years of product experience in building and scaling B2B SaaS cloud products in connected devices, data management, and edge management space. I have also worked across different industries, automotive, marketing tech, and also industrial automation space. Like I said, I'm excited to be here. I did throw my contact info. I would love to connect, discuss more. So please feel free to reach out. Again, thanks, Sudha. Before I dive in, thanks again for having me, and I'm really excited. So the way we discussed this topic was that I have presented before on digital twin. I have really dived deep into this topic. As I had some time, I had started looking at, like everyone else, we're trying to learn what generative AI is, the AI agents being a new thing, what it is. So I started reading a little bit into it. And I was just throwing some information together, and I told Sudha, hey, can I come in and talk about it? Because and just share the information that I have currently. I look forward to diving further more into this topic and learning a little more as I go through it. And but this is what I have so far, and I would love to share this with you all.
Just to be clear, guys, the way Sneha was saying is, I said, you've been talking about digital twin. It is so easy for you. So why don't you show us how it is built? And she was saying, oh, these days it is standardized. There's so many technologies. So I said, why don't you bring one of them and show us? And she said, I'm going to show something better than that. We are just not going to show how to build something, because this group here is group of innovators who want to learn something and then go apply that in various industries, in various places. And so I hope we will, go past the basic building of digital twin.
Yes, absolutely. Okay. So just for the sake of introduction and such, we all know what digital twin is, but it is a virtual representation of a physical world asset or a process. And usually it is built in order to generate insights or drive any kind of efficiency using automation, just like the video that we saw from GM, right? You have the assets or the interactions of the digital twin could be from humans, could be from other digital twins, or just basic systems, right? Are trying to gather information. We have different types of digital twins. I think the reason I wanted to bring this, it does sound basic, but sometimes we either pull ourselves way too ahead, way too at a higher level, or we go down way too granular in order to think of what a digital twin is. But digital twins are of different types, right? You can have a one for the parts, a very specific part, in order to improve its mechanical or electrical aspect, right? It could be of a product as a whole that has different parts, and now you're trying to improve the product itself. You're trying to improve its mean time between failures, or track mean time to repair, and improve all of those metrics. And that's why you're creating a digital twin. It could be of a system, of a whole entire system, like a power grid or a water management system or a traffic control system, where you're trying to, again, trying to remove inefficiencies or failures or predict failures. Digital twin can be of a process. It doesn't have to be any physical product as such, but a process, a very complex process. For example, a warehouse management process or a quality tracking process to meet a specific governance standards, right? So these are the different types of digital twins, and I think agents AI, as we go to talk about it, would actually come into play at different for different types of digital twins, and also at different level of complexity. It doesn't have to be something super complex. As I'm learning about it, it doesn't have to be something complex. It could be just a response to a specific stimuli in a part. Could be something that an agent AI is helping you improve, right? This is at a very high level, again, just diving a little more into digital twin, a functional representation of what a digital twin is. I think sometimes whenever I speak to people, when we think of digital twins, we think of a 3D representation of a physical device, which is true, which is absolutely true, but it is one way of representing the model itself. It could be represented in different ways. It could be just a dashboard. It could be like an actual AR VR cool model. It could be a 3D visualization, like how you have in a CAD model, right? It could also be just basic reports that's coming up. It doesn't have to be a cool representation always, right? But again, why do we use and who uses these models? Just wanted to quickly go through these personas that are using these models, right? You have operations manager, you have
Sorry, Sneha, can we just, give a one-liner for those people who are not actually like experts on digital twin itself, right? So the digital twin is a digital representation of a physical asset, which means there are sensors. Is that right? That the starting point is you add sensors to anything that you want to build a digital twin of, you collect data from that.
Yeah.
That data creates this CAD model or this 3D model or any other visual view of this particular asset. So if it is
Exactly.
it's a
Exactly.
fund. Yeah. Okay.
Absolutely. So yeah, I think this is what we're trying to show in this picture here is that you could have a physical part, a physical product. It could just be a system as a whole, like I said, or it could be a process, right? But all of these need some level of, there has to be data that is coming in. The source data could be sensor data, or it could be coming. So most of the times it's not just one, it's multiple. Usually a model is created through multiple data points. One could be sensor data, the other could be a OT system like PLCs, your distributed DCS systems, sending you that more information about that specific part or product. There could be IT systems that is telling you about, hey, where was this part? What is this part number? Where was it sourced from? Etc. And then, of course, there's a CAD or design aspect of the product itself, which is displayed in the form of a model, right? So, in order to build a model itself, you need multiple data points, and depending on how complex your digital twin is, if it's a simple digital twin, it could be just maybe one or two data sources. But if it is a complex digital twin, it will definitely have data coming from multiple sources in order to just represent it, just to represent what this digital twin is. And then you have other aspects of it. Okay, how do I simulate some level of data in order to test a specific occurrence or a specific design, right? It could be something else, but the first step is creating the virtual digital twin itself, which is a virtual model itself based on multiple data points, like Sudha mentioned.
So I have one example I want to bring just to drive the point home. So there's sensors and there's data, multiple sources. Thank you for that, of data that is collected. But it is not just, it's not just data of a product, right? There's a lot more by which a model is created. So there's like the physics of it. For example, I just want to give a simple example for others because this makes it easy for me to understand. So I keep my phone out in the sun, and then it can take only so much heat, and then it switches off at some point. So there is a certain amount of heat that this particular device can take. So all the different sensors of, in this case, it's the temperature, right? And if it continues to heat at a certain point, it might melt. So collecting all the data from this particular device, which is my phone, could create a digital representation. And when I'm sitting in the sun, before I reach that temperature, I could run a simulation which says, oh, you're going to reach that temperature, you need to take it out from the sun. And this could be for anything in industry. So for safety, it could be in the car and all kinds of things. But it's more than just the raw data saying temperature is now 99 or 98 and a time series. It's also about the physics of it, correct?
Yes. So yeah, and it could be different goals for different people trying to consume the digital twin, right? So like on the right hand side, you have different personas trying to use this digital twin, right? An operations manager would just want to increase the efficiency of what a specific digital twin or the specific product, right? A product, process, even a system, right? Reliability is purely concerned about the quality, right? Hey, how can I make sure that I'm meeting certain metrics from a quality perspective? You have production engineering, you have maintenance engineering. So people like maintenance engineer might be interested more in the predictive maintenance, like you mentioned. If something fails or something is about to fail, please let me know, right? You can have different goals for different kind of people trying to consume this twin, and then they can have different rules against which how they would want to use the twin. Like, hey, like you said, hey, if it reaches a certain temperature, please let me know, right? Or before it reaches a certain temperature, it's trending towards it, let me know, and I need to know that this is going to fail, right? And then, of course, these are just simple things, but you can also deploy models like AI models in order to come up with these inferences, right? If it does require some complex modeling. But it doesn't have to be. Just wanted to say that it varies. It goes from a simple condition, if temperature above 100, let me know, to a complex AI model that is taking in multiple parameters to come to an inference to say, hey, look, there could be an issue in another 5 days, which means you have to take this to create a maintenance ticket, which needs to be serviced in the next 24 hours, right? So it could be as complex as that versus and as simple as a notification. But like Sudha said, it is not just, it's just not the representation, but after you have the representation, what do we do with it? How do we use it? Is what is more powerful about the twin itself. Good. Sudha, can I?
Yes, thank you for that,
Yes.
Sneha. Thank you.
Okay. So what are the challenges with it? So digital twin is not a new thing. Like Sudha said, she shared an old video from GM. It's not a new concept. It's not something that's just recent. It has been there for a long time, but it does come with its own challenges, right? You always, there is a concern about real-time communication of data, the latency around it, because, there's connectivity issues. The large scale computation. So if you want to do something more complex, it is limited today, or it just depends on how the model itself is deployed, or what resources are available for the model. Do you have computation on-prem or on the site where the physical model is, versus do you have it in cloud? Right, and then also the actual connectivity itself with the physical asset, because you have some industries that do not allow for internet connectivity within the for the physical assets, for the physical assets to connect to the outside world over internet. So these are the common challenges that are present with digital twins. People have come up with different ways to mitigate it. One of the things that I thought I was trying to read into is how AgentAI can actually help with mitigating these challenges. And hence, I started digging into what AgentAI is. Just a quick overview about what AgentAI is. It is it's a program that will interact with its environment. So whether it could be human input or a system input, collect the data, and then use that data to perform some self-determined tasks, right? Like it would take a goal from a user. So a user would say, or user or a system would say, hey, this is the goal. It would take that goal, it will take the data, all the data necessary, use the tools that it is available to the agent itself in order to get more data, and then come up with self-determined tasks. I think this is the most important part of it, that it creates tasks, self-determined tasks, in order to achieve that goal. It has different components, like it has sensors, actuators, it has its own memory, storage, and of course, the availability to the knowledge base itself. And these components actually help with mitigating some of the limitations of the digital twin. So let's go into what are.
Can you bring this to a full screen mode, because we are able to see the next slide taking up half the screen.
Oh, sorry, I thought you were seeing my full screen. Let's see.
It's still showing the.
I think I'll just quit the. Is this good?
Yeah, this is good. Yeah, this is good.
Okay, thanks.
Thank you.
Just give me a second. It is, I want to be able to do next. Yeah. Okay. So what are the features about AgentAI that actually help digital mitigate challenges of digital twin? The first one is it is autonomous and rational. It can take information from its surroundings and make decisions that are based on the data, right? It will come up with its own tasks. It will come up with its own planning and task list in order to achieve a goal. I think that is very key and key differentiation between what a digital twin can do with and without AI. With and without agents AI, right? Without agents AI, you have to tell digital twin as to what it needs to be doing. What are the steps? What are the conditions? With agents AI, you get that autonomy, or you render that autonomy to the digital twin in order to come up with its own set of predetermined tasks in order to achieve that specific goal. You don't need to constantly send prompts with new instructions. You do not need to do prompt engineering with agents AI. It is capable of coming up with its, like I said, predetermined tasks in order to achieve the specific goal. Of course, you have to make sure that the agent's AI has the necessary tools, necessary knowledge base available. Given that, assuming that's available, it doesn't need constant prompting. It is more flexible and versatile than traditional programs. One of the things that it can do is approximation. It can handle complex and unpredictable tasks. What it does, basically, it comes up with approximation of what could be done in a specific scenario in absence of the information that is required. If in a traditional digital twin, if a specific information is not there, the digital twin would not give the right may not give the required output, right? In case of agents AI, it will come up with a approximated output, and it will also tell you that this is an approximation, right? But again, as a basic assumption being agent AI has the necessary tools and a knowledge base in order to make these decisions. So just if you just stack up what is a digital twin versus a digital twin with agents module, right? What would the components really look like? So on the left-hand side, it is just pure digital twins and the modules that would be present, right? You have the physical asset or process, you have basic data capturing, data processing, data storage layer, and then communication between the twin and the physical asset. The twin itself would consist of the virtual model. Again, it could be in different formats. You would have then twin analytics and dashboarding in order to communicate what with the user or with the necessary system. And then, of course, there's simulation, which is a very core part of the digital twin itself. With Agent AI, the additional modules that you would add on top of the digital twin, like I said, are the tools for Agent AI. So the main part being the task planning, the memory, the knowledge base, the storage memory, the tools that are available for the Agent AI module. So for example, if you need that Agent AI model to use the weather app, or use weather as an input to determine certain goals, right? To achieve certain goals, it would need to make that available to the Agent AI module itself. And then, of course, there's action and feedback, along with an auto sync across the physical asset. So you would need some way to some kind of a feedback loop, some kind of reporting, and then, of course, continuous learning in order to make sure that it is continuously meeting the goals with the necessary accuracy. Also, the biggest thing about Agent AI module is now it can take over from the digital twin to communicate with other twins, other agents in the environment in order to, again, get input or give output to the whole system as a whole. So
Sneha, can you pause for a minute? So I remember I think it is in my artificial intelligence and connected product course on LinkedIn. I have a lesson on digital twin, and I remember going through this saying you can have a digital twin without AI. I was teaching AI. That was the main purpose of the course, and we kind of struggled whether we should have that module. So the point I want to make is we can have a digital twin just collecting data and running some kind of simulation without AI in the picture. Totally, right? And it's going to take the time series of data and then project, like in my phone case, that it can project and say that it's going to get heated up, right? Or you could bring in external data sources like the weather and say it's a hot day and that the environment is heating up and the prediction is that it is going to reach the temperature. Yeah. And that's the adding more data sources, right? And so I remember there was this concept of cognitive digital twin, again, pre-LLM world that was evolving. So what I would like you to kind of slow down and tell us again a little bit on this, what you were saying, the different modules. And one of the things I heard is, yes, you can just do digital twin without AI. That's the data part. And the second thing is now you can bring AI to bring in multiple data sources and do some simulation. That is still feasible with just AI, right? The traditional AI.
Yeah.
But what I heard you say was it makes decisions, it interacts with the users, and it is doing some feedback loop. Those are new. Those are not possible without agent AI, as in the LLM world interacting with the user and being a little bit more autonomous. Can you pause a little bit and then tell us, or maybe if you have it later, I can, back
Yeah,
off it.
I actually have certain use cases that can be achieved using digital twin and agent AI.
Okay.
So if you want, we can quickly jump to it. I mean, so I think at the face of it, if you look at the use cases, you feel, oh, you can achieve them, like real-time monitoring, predictive maintenance, autonomous control. But autonomous control is maybe a different part, but specific simulation and scenario analysis. These can be done today too, right? Like you don't even need AI, let alone agents, AI using LLM. But you don't even need AI for that, right? But the point is the quality of what you get from these use cases, right? It is what is that, it's the problem definition, right? In a problem definition that tells me, hey, collect all the data for a specific product or specific twin, and just give me the telematics of it, right? That is just basic data processing and data communication, right? You're just basically sending in heartbeat of a specific product, right? Let's just say, hey, give me the heartbeat, which means, hey, what is the current, like you said, temperature, what is the current memory, etc. So that's just basic information. There's no AI, there's no intelligence involved in it. It's still called real-time monitoring, right? Because every 5 seconds you're getting this information, so you're real-time monitoring. But the question is what Agents AI plus Digital Twin helps us achieve is improve the quality of the problem itself, right? You're going to be able to say, okay, I want to be able to do real-time monitoring of my physical counterpart, right? Physical counterpart asset. And I want to be able to detect anomalies or any kind of deviation. Plus, once that happens, once it's detected, you need to make sure that the right maintenance flow is kicked in, or the right maintenance flow is kicked in, and and make sure it is addressed, right? So you can improve the quality of the definition of the problem itself, and then give that goal to the agent's AI, which will then say, okay, now I'm not just communicating, I'm not just moving the data from here to there. I'm now trying to say, I'm trying to basically solve the problem of detecting it or fixing it, and then making sure that it is fixed. It remains that way, right? So I think what it does is more than the tech aspect of it, it's more about how it helps you improve the problem statement itself, around predictive maintenance. Around, again, for predictive maintenance, you can do it at different levels. It's just how well it helps you just build the problem statement itself, is the main takeaway that I got from digging into digital twins plus agents AI. And I put together some of these scenarios here that would help you achieve certain use cases like optimization and decision support, right? Like you can use the agent AI to assist human operators by providing some basic insights and recommendations, which helps them then enhance their decision-making process, or even give the certain aspect of decision-making to agents AI, and how you transfer that role over to the agents AI, the intelligence part of it. So that's what that's what I've been learning. It more than it just expands the problem statement itself. Hope that helps. Does that help, Sudha?
Yes. This is helpful. So it is more than just automation, right? There's a lot of decision making, and there's a user control on what those variables are. So I'm thinking, because I was teaching digital twins from a car perspective. So if the data from the from car parts are talking about the how the different parts are performing, some, like you spoke about different stakeholders. So some stakeholder might want to know when the parts will fail. somebody would want to know, okay, I want it to have a safety aspect. It should be turned off before and run a simulation for safety. So it could be safety or performance or maintenance. There could be different goals. So even when collecting the same data, you could do that, right? Somebody could set that.
Also, there's the other aspect of it is like at the end of the agent's AI, it doesn't need to be just a human. It could be something like a robotic arm that is performing certain actions based on an output from an agent's AI workflow, right? Now you have the confidence of delegating those decisions to the agent's AI based on simulation, based on testing, to say, okay, now I think we can delegate a task as critical as decision making for a robotic arm to an agent's AI-based digital twin. And I mean, again, like I said, today it happens, but it is very fixed. It is a very strict set of tasks under strict set of conditions, which are predefined. Anything new, it was not going to work. But in this case, you can actually let the agent's AI delegate certain things to the agent's AI, where in an unpredictable scenario, it will make a decision. It will make a decision within the boundaries of what you provided, but it will make a decision. Right? If you're trying to reduce downtime on a line and you want a robotic arm to make a decision as opposed to just go bah, like you want it to make a decision, and it will make a specific decision, right? Within the boundaries of what you give it. So again, like I said, it helps you enhance the problem statement itself by delegating some decision making or more decision making to agents AI.
The other thing is interesting for me in what you're saying now is it is not rule-based, because the way we are going towards automation in the LLM Gen AI world is more than, first there is a human touch point, so there is kind of interaction with the human, but also it is not rule-based. I mean, one of the things that I have struggled with when they said we are going to use Agent AI and build e-commerce systems and whatnot, it looked like there was a human interface. They were chatting, helping find products and whatnot. But then on the back end, when they were automating things, they were creating rules again, right? If it is going to be rule-based, that's not AI. So now what I'm hearing is you are truly making it autonomous with agent AI, making decisions, but you get still user control to say my safety parameter is when the product reaches this much temperature. I'm stuck on the temperature example. And if you go to your production example that you don't want downtime, then it pulls that bad product out, or it changes the assembly line, or it does I'm thinking the robotic arm doing that. But it is making those decisions within the parameters that you give. It's not rule-based, but it's still making autonomous decisions. Is that a right way of thinking about it?
Yes, and you would want to. These are all high mission critical. If you see where digital twins are implemented, most of them are mission critical, still conservative scenarios where safety is important, where downtime is not tolerated really well. So these are really mission critical applications or use cases. So safety or guardrails are going to be very critical. And I think the more I read about it, the more I am understanding agents AI, the guardrails and safety aspect is more. It's easier to mention those. It's easier to describe those, or be descriptive about, hey, these are the guardrails, or this is what you need to operate within, right? So it's becoming more and more easier to give those to the agent's AI, and then say, okay, within these guardrails, you can make a decision, right? So that's what I'm learning. So I think autonomous is great, but also guardrails are important. So yes, you're right. I think that's what I'm agreeing with you. That's what I'm learning about agents from an agent's AI perspective, is that it is autonomous, but within the guardrails of the operations.
So this is fantastic, because one of the things I like in my classes is students come with their own business experience, and then it kind of bring that acumen into whatever we are building, right? Earlier I was thinking it's the metrics, right? You define certain metrics that would feed into this. Is that how it operates? Like, if there's a person like Suresh who understands warehouses and they're deploying at this agent AI with digital twin in a warehouse, is it going to be metrics, benchmarks that's going to kind of set the guardrails, or is there more?
I think we should hold that question till we see.
Okay.
the
Okay.
video that we have towards the end of I think that's going to answer your very specific use case too. Okay, so I think moving to the advantages of digital twin, advantages of agents AI to digital twin. I think the first and most important is autonomy. You do not have to be, like I said, you go away from rule-based. The scale, I think agents AI, given the resources, helps you scale across physical and virtual environments, and it also helps you mitigate fidelity issues. The biggest concern with digital twin, whenever you say there's a data connectivity issue, data fidelity issues, is if you have it to if you give agents AI the tools and the knowledge to make some learning based approximations, it actually helps you mitigate those data gaps, the gaps concerned, or fidelity concerns due to connectivity issues. I think these are the three main advantages that I'm seeing that from agents AI to digital twin. Having said that, I think now I have the video, Sudha. We have 10 minutes, so I just want to make sure, in interest of time, we move quickly to the video. Let me know if you can hear the sound, just a quick check.
The future of
Can you hear the audio?
Yes, yes.
industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins. This Omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the NVIDIA Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using NVIDIA Metropolis, and AMR route planning with NVIDIA cuOpt. Software in loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. NVIDIA Metropolis updates and sends a real-time occupancy map to cuOpt, where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency. With generative AI-powered Metropolis vision foundation models, operators can even ask questions using natural language. The visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMs to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
So I really wanted to share this video because actually I started thinking of the whole concept after I saw this video. So I think, and there are some tools that are mentioned from NVIDIA in there. I just started digging into OpenUSD. So I think it is pretty cool. It's not, I mean, OpenUSD has been there for quite some time. It was started by Pixar. So, but I think leaving the tools aside, it's just the whole concept. Hopefully that helped understand what the concept is. So that's all I have from slides perspective. So
Can you get out and share? I want to see if people have questions. Yes, I'm seeing a comment about, can we share the video of this? So
yeah, I can put in the chat.
I want to see anybody here who happens to be here in the Zoom. You get obviously the privilege of asking questions if you want to do that. Otherwise,
I have one question. So this is very near and dear to me.
yes.
Excellent presentation. So one question I have is, so digital twin is a software solution for a physical hardware. Now, softwares do go down, and when you're bringing it back up, so what do you start from, when the hardware starts, or how do you gather the data to have the memory of what the digital twin has and stuff like that?
Yeah, I think there are multiple mechanisms, even without agents AI. In my past life, we've had store and forward mechanisms, right? I mean, of course, based on how much memory and resources you have available to you, there are different ways in which you can have store and forward methods where even if the connectivity is not there, you can store that information that needs to be sent. And once the connectivity is established, you can send it. I think one of the interesting parts that I was reading was, and that's where I put in the learning-based approximation is, in absence of data or gaps, based on the past experiences and past knowledge base, it is able to say, okay, given the specific conditions, these could be potential values of the data or the data gaps that are not available. So even after store and forward, if you have certain gaps in the data because of connectivity or whatever, it is able to come up with an approximation value. I have seen this concept before, even without agents AI, but it's the accuracy of it, right? I mean, there are tools that does approximation even today, but just the accuracy of the approximation, given the resources available to the agents AI, I think is going to be the key for mitigating data gaps.
So in the example that you shared, Sneha, so where there's a robot moving on the industrial flooring and things like that, how much of data is enough? Or, what is the data that you would be saying, okay, maybe this is not there or that is not there? How do you put the boundaries on how much of data is needed to make sure that digital twin is accurate representation of, the physical device?
So I think there is always going to be, it's going to be based on use cases, first of all. Second of all, it would be, so first question is then the first question that comes up is, how would you know it's approximation based
Yes.
decision? This decision has been made on approximated data as opposed to a real data. I think it just goes back to looking at the results itself, like going through the test bounds and saying, hey, how accurate and precise is the recommendation that is coming from agents AI, or how accurately is the agents AI meeting the goal that was given to it, and then over testing over multiple iterations, you come to a confidence level to say, okay, I think again, this is me understanding based on my understanding projecting, this could be a potential way to determine this is the accurate level of approximation. There has to be some level of right, like guidelines around how you even decide approximation correct, right?
That's right. Yeah. Oh, thank you, Sneha. Yeah.
Okay, thanks, Suresh.
Thank you.
Sneha, I have a question. I remember when we were talking about digital twin and autonomous vehicles, we had a class by Dr. Varga from Volvo, and he was talking about how they build microservices. And when you explain the whole acronym of the NVIDIA tool, we try to be very agnostic to any kind of brand. We are not endorsing, nobody is like, we are not biased against any one particular brand or technology. I just realized that it said microservices in there. So is that the standard way? So essentially, if somebody is watching this and they want to bring digital twin and make it connect to autonomous vehicles, autonomous agents in some form, they start by building microservices. Is that the starting point? You build you take your asset, start building a microservice, connect it to the cloud, then connect the data and do whatever else other use cases based on what you're saying.
Yeah, I think it's all implementation phase. I think I remember the weekly Wednesday session that you're talking about from Dr. Varga. I think it is very implementation specific as to what tools that we would use in order to even build a twin itself. Right. I think and at what levels do you need the microservices to be built and implemented? So I think that I would just say that it is very specific to the implementation that you would want to be used.
Are there other ways
holding Sorry. Your leg with that HR comment,
okay, somebody's coming. Guys, can you go off off mute, please? Yep. Okay. I'm going to ask my question again. So when I was teaching this in class, we simplified it and we said, okay, you can build a microservice. So you take an existing asset, collect all your data, then build a microservice and let it do one thing and send it to the cloud and then get your answers. What would be other ways of getting started? Or basically, I'm trying to help our learners understand this is great. Is this about using an API and experimenting in the
So
cloud?
there are
Or is
multiple
there like a
tools
product
actually.
version?
Yeah, no, there are multiple tools. I put in some links as to if you have known to build, and these are from different companies, right? Not specific company. I've dropped in some links for Amazon, for Azure, for IBM, and also like a couple of papers that talk about how you start about building a framework for digital twin. So that I think in interest of time, but we can also cover this in detail in some of the other sessions, but it would be a good follow-on topic to dive into. But I have put in the resources that would help participants to understand how do you go about or how do you start about it.
Okay, so it's here on the chat for those of you who are watching on YouTube. I'm not coming and posting all these links. I was posting some of the links. One thing we are going to do is on Business School of AI on LinkedIn, we are going to come back, tell you where the recording is. We are going to come and share the slide and things like that, right? I'm hoping you'll give us the slides, Sneha. It's okay. Yeah.
Yeah.
Yes. And these resources that Sneha has listed here, I will include that in the newsletter. We do like a the Jamthe newsletter has a long list of reading material once in the beginning of the month, though the newsletter goes out every week. Ranin has made sure that we tell you very pointed, useful things each week, and then we give a big long list of a lot of reading material, a lot of jobs and stuff. So I'll make sure this goes in the July issue when you get the long version of the newsletter. So I see every possible tech company has some kind of digital twin solution. I remember when we were teaching this for autonomous vehicle, it was all IBM that we were using as an example. This is fantastic. Okay, a good session always ends with asking us to want more, and you've left us with that. So I hope you will come back and give us more. Tell us what you're building and what you're doing with that. So I appreciate that. So with that, I'm going to wrap up, guys. Thank you everyone who joined us on Zoom. We open up the Zoom for people who want to come here and engage and ask questions. And so it's like a good discussion instead of like running it like a big webinar. There is one question from Adam. It says, what are some good architecture tools for many systems beyond microservices?
Yeah, I think that those links have those, Adam. So there are 3 different tools talked about from 3 different companies in the links.
Thank you.
Yeah.
Yeah, I'm interested in stuff that's bigger than just microservices, multivariable. It borders on SPC, statistical process control, especially when you start talking about alpha and beta error, or what are your error bands, or how significant is that value to your understanding? And from what I'm seeing, I'm still new to some of this. You could start it from both sides of either pulling the data in from the start and just having a large data tree to look at. I've done that with statistics. Or actually architecting a serious or a microservice. I'm still working with some of that. So
Yeah,
thank you. Thanks again for a great class.
Thank you, Adam. We all are new to this, by the way. We all are learning. Yes.
Thank you so much. No, I appreciate that. So with that, I'm going to wrap up. So what I got is digital twin. We've heard about it. One of the things I'm going to do is we had a couple sessions here at Weekly Wed over the years on general digital twin, microservices with digital twin and autonomous vehicles. And there's been a bunch of GE sessions too. So I'm going to go find those content and see whether we can share that back with you. So follow us on Business School of AI. That's my school student alum community on LinkedIn, where we'll be sharing stuff. And then, of course, we'll share all these links that Sneha has posted on our newsletter. So thank you very much, Sneha. I want to, like, after listening to you, I want to actually go build something. So one of the things we do is, as a community, we do like projects where we all collaborate and publish a paper. This lends itself to publishing a paper very naturally. I've not seen this topic beyond the NVIDIA presentation that you showed. All these companies which have products are commercial, use my technology, and here's an example kind of videos. I have not seen research papers on this, so I would like to do something more with it. So if somebody wants to collaborate on a research paper, I would like to go build something for real, like take some real IoT and go build something. I would like to build an autonomous vehicle, but maybe we can start small with IoT, adding some sensors, something useful, With that, I'm going to wrap up. Thank you, everybody. Yash will be back next week. And by popular demand, people are asking, okay, tell us AgentAI. I mean, this is digital twin with AgentAI. And there is an AgentAI lesson in my Gen AI course on LinkedIn Learning. There's digital twin lesson in one of the other connected product AI lesson also. But come back here, and we are happy to continue this learning session. I think we'll make this about making agent. First, we'll teach AgentAI. Yash is going to be back next week for weekly wed, and we're switching to this 9 a.m. time, and we're going to bring a new set of speakers, people you have not seen in the past, so that we actually say, okay, how does AI do something useful? So when you bring IoT and physical assets, now you can touch and see it, and the examples, we can relate to that instead of just chatbots, or can we visualize the chatbots? There's a whole new concept evolving. So we're going to start off a series in the coming month, all focused on, in July, we're going to focus on AgentAI, visualizing chatbots, so it does something more useful, go past microservices. That's going to be our series, again, to give you, practical application use cases. But what we are trying to do here is to get you to think, apply what you're learning. So come talk to us. And I hope to see you back on LinkedIn if you're chatting at the Business School of AI, or I'll see you back here at Weekly Wed. Thank you, everybody. Stay safe and see you. Bye.
Thank you. Bye, Sudha.
Bye. Thank you so much, Sneha. Appreciate it. I'm going to stop the live stream. Thank you, everybody on YouTube. You can join us at Business School of AI on LinkedIn, where we'll continue the conversation. If you're not familiar with the newsletter and stuff, you can just follow there, and we'll share everything. Thank you to Ranin, Pariya, Deepika, everyone who has made Weekly Wed happen. I get to party and come and have conversation.